Hello again and welcome to Physics De-Mystified, GCSE Physics. This is Chapter 3, Video 1. This time we're going to be looking at electrical power. Now, power, just like any other power, electrical or otherwise, is always a measure of the rate at which a device uses energy, in this case electrical energy. So an appliance that uses more energy per second therefore has more power. And remember, power is measured in watts. So an appliance that uses, say, 1 joule of energy in 1 second is going to have a power of 1 watt. It's 1 joule per second. So take the example of this light bulb. It has a power of 60 watts and therefore it uses 60 joules of energy every second. This light bulb, however, has a power of 100 watts and thus uses 100 joules of energy per second. Now the formula for electrical power is power equals energy divided by time. Remember, power is measured in watts, energy is measured in joules, and time is measured in seconds. So here's an example of an exam question, in this case working out how much energy an appliance uses. Now you can pause the video at this point, have a go yourself, and then we'll talk through it. A hairdryer of 1200 watts or 1.2 kilowatts is used for 2 minutes. How much energy is used? Okay, now you can pause the tape and have a go at this. Okay. Energy is power multiplied by time. So remember to convert minutes into seconds by multiplying by 60 first. So the energy used therefore is 1200 watts multiplied by 120 seconds, which equals 144,000 joules or 144 kilojoules. Here's 2 more examples of questions. The first is how to calculate the power of a device using its voltage and current. And the formula to calculate power from current and voltage is electrical power equals potential difference or voltage multiplied by the current. That is, the higher the current for the same voltage, or the higher the voltage for the same current, the higher the power. Now a games console operates on a voltage of 230 volts and a current of 0.8 amps. So calculate its power. Stop the video now and have a go. Okay, power equals voltage multiplied by current, which is 230 volts, multiplied by 0.8 amps, which equals 184 watts. Now the second question shows how to calculate the current required to operate a device according to its power rating and the voltage required. In this case, an electrical drill operates on a voltage of 230 volts and has a power of 400 watts. So you can calculate the current drawn by the drill. The current equals power divided by voltage, which is 400 watts divided by 230 volts, which equals 1.7 amps. As part of the GCSE syllabus, you need to understand how and why domestic electricity bills are calculated. Now you may be surprised to hear that bills for energy are not calculated in joules, which is the unit of energy, of course. Simple reason for this is that so much energy is used by homes that a bill in joules would be impractical. It's more convenient to use a unit that uses smaller figures. Now a typical appliance uses a lot of energy. Now the hairdryer in the earlier example, for instance, uses 144,000 joules in just 2 minutes. So for domestic bills, it's just more convenient to use a larger unit. Enter the kilowatt hour. This is a larger unit of energy. An appliance with a power of 1000 watts, 1 kilowatt, switched on for just 1 hour, uses 1 kilowatt hour of energy. That's 1000 times 60 times 60 joules, or 3,600,000 joules. That's one appliance for 1 hour. So imagine the number of joules for the whole household for 3 months, a quarterly bill. You can see why billing in joules is just not practical. So our final question example is one related to kilowatt hours. A refrigerator, a fridge with a power rating of 1.5 kilowatts is switched on for 8 hours. So how many kilowatt hours does it use? Well, the energy equals power multiplied by time. So that's 1.5 kilowatts multiplied by 8 hours, which equals 12 kilowatts. Now note that as we are dealing with kilowatt hours, there's no need to convert the time into seconds. Now electricity providers refer to kilowatt hours as units of energy rather than joules. Now the cost for your electricity can be calculated by multiplying the number of units by the cost of one of those units. Fairly straightforward. The formula is cost equals number of units in kilowatt hours multiplied by the cost of a unit. So, in summary, Electrical power is a measure of the rate at which a device uses energy. Power equals energy divided by time. Electrical power equals voltage times current. When calculating domestic bills, kilowatt hours are used as a unit of electricity, and cost equals the number of units in kilowatt hours multiplied by the cost of a unit. Well, that's it for electrical power. Next time we're going to be looking at electricity in the home. So until then, goodbye and keep wondering about the universe. Oh, and don't forget to subscribe to us and click the bell below so that you know when the next videos are loaded up.